Hey, welcome back to another episode of Math Cafe, Enough Pie for Two. Hey, Mrs. F.
Hey, Mrs. H. I know what you're thinking, but no, there's still no pie.
Seriously, man? I'm gonna leave. That's the only reason I'm here.
Yeah, sorry to disappoint, but apparently that's what I do.
Great. Alright, let's get on anyway.
Alright, so today we are going to learn about the relationship between the center of the circle and a line segment that joins 2 points on that circle.
Oh, a chord.
Yeah, pretty much a chord.
Okay, perfect. So for today's video, you're gonna need the worksheet, a protractor, a ruler, and a pencil. Make sure you have those supplies handy.
Alright, well, let's see you in there. Let's go have some fun.
Let's get started!
And we'll follow these directions. Let's cut out the circle that is attached to your worksheet using scissors.
Okay, so you might want to pause the video here and cut the circle out.
Alright, let's label, now that you've had your circle cut out,
Okay.
let's label the center of the circle with O.
Okay, so this is... Okay.
Now you need to choose 2 points on the circle and label them A and B.
Okay, so any 2 points?
Any 2 points as long as they don't go through the center of the circle.
So A, B.
Those look pretty fancy.
Alright.
Alright, using a ruler now, let's join these 2 points to form a line segment AB.
Okay, so I'm going to join point A to point B.
Notice how this line segment does not go through the center of the circle.
Perfect.
Alright, so now you need to fold the circle so that A coincides with B.
Alright, so I can't actually fold it in half since it's on a smartboard, but imagine I was folding so that A overlaps on top of B.
Which is what coincides means.
Perfect. What's next?
Alright, now you need to crease that fold at that part where you've made the fold. Open the circle and then use a ruler to draw a line along the fold.
Okay, so I know that mine would look something like that.
Perfect. Okay, now you're going to mark the point C where the fold line intersects A and B. And intersects means crosses that line.
Okay, so I'm marking this point here, point C. Okay.
Alright, now you need your protractor. So let's get out your protractor and we're going to measure the angle formed at point C
Okay.
with the line, the fold line that you've created.
What's this here? Okay. Okay. Perfect. So I'm measuring angle BCO. And according to this, it looks to be about 90 degrees. Okay. Okay.
Alright, next we're going to talk about the line segments now that have been formed once we've made that fold line. So notice that AC and CB are now new line segments.
Okay, so we have line segment AC and line segment BC. Okay, and what do you want me to do with those?
Now we're going to take our ruler out and we're going to actually measure the length of each of these line segments.
Okay. Just gonna line this up. Alright, so it looks like, oh, it's about 5 centimeters in total. Line segment AC is 2.5 centimeters, and line segment BC is also 2.5 centimeters. So I'll just record that down.
Let's record those values on your handout as well.
So make sure you're measuring your 2 line segments and the lengths of each into your chart. Perfect, now what?
So now we're going to repeat the steps 3 to 8 for our other 2 points, D and E, on the same circle.
Okay, so you're going to repeat the same steps again for 2 new points on your circle at home, and I'm going to do the same thing here on the smartboard. So I'm just going to get rid of this first. Okay,
Now you're going to repeat the steps that we just did on the same circle, but using 2 new points, D and E.
Okay, so you're going to do the same steps again on your circle at home, and I will do the same here on the smartboard. So I'm going to draw in point D, point E.
It's important again that we make sure that those 2 points will never cross the center of the circle. Now we're going to use a ruler.
Okay, so first, actually I'm going to draw a line segment joining point D and E.
and you'll use a ruler to do the same.
Okay. And then you will fold, again, just like you did in the first example, and unfold that crease and then draw a line through that. Okay, and so I know
Make sure D and E match up when you fold, and then you will draw with a ruler again the along the fold line.
Perfect, just like I've done here. All right.
Let's mark this new point that's formed where the fold line intersects D and E as F.
Okay, so this will be point F. Okay?
Now we're going to measure that angle formed with your fold line and the line segment DE. So we're going to measure the angle between those two.
Okay, so again, you'll use your protractor at home and measure, and I'll measure here. So I'm going to measure the angle DFO. Line. And in doing so, I'm getting a measurement of about 90 degrees. And make sure you record your angle measurement that you got on your chart as well.
So now we are going to measure again the line segments that are formed at this intersection. We are going to measure line segments DF and EF using our rulers.
Line segment DF and line segment EF using my ruler. Okay. So it looks like in total they're about 3.4 centimeters, and line segment DF is about 1.7, and EF is also about 1.7.
So remember when you're recording your line segments that these values could be different because you were dealing with a different circle.
Perfect.
So what patterns are we noticing about the line segments then and their fold lines?
Okay, so we're noticing that line segment AB and line segment DE, the fold line between both of them is forming a 90-degree angle, so we should probably draw those in. And we're also noticing that it's cutting that line segment in half. Okay, so I guess we can say that the fold line is a perpendicular bisector to line segment AB, and again, the fold line here would also be a perpendicular bisector to line segment DE.
Okay, so vocabulary, perpendicular bisector. So the definition of a perpendicular bisector is where the line bisects it or cuts the other line segment in half so that these are equal lengths, which we can also record on here by using these lines.
Perfect.
As well, for it to be perpendicular, it has to form a 90-degree angle, which we've already drawn in.
Perfect. And another important vocab that you need to put into your chart would be the definition for line segment AB. So a line segment that touches whose endpoints are on 2 points on the circle, so right there and there, is called a chord. So this would be chord AB, and this would be chord DE.
All right, just to summarize, why don't we talk about the chord properties that we know from this circle now?
Okay, so looking at both of our chords, it looks like that the perpendicular bisector, we know, cuts the chord in half, forming 2 equal line segments. It's also perpendicular to it, forming a 90-degree angle, and it seems to be with these 2 chords that the perpendicular bisector always passes through the center of the circle.
Perfect. That seems like great observations and also become our chord properties.
Okay, so now let's use this knowledge and apply it to examples.
Okay, so let's turn to our practice question 1 in your handout. In this case, we're going to be looking at solving unknown angles in a triangle knowing our chord properties. So point O is the center of the circle,
Right?
and line segment OC bisects chord AB.
Perfect.
Let's look at angle OAC,
Okay.
and we know that that is equal to 33 degrees, as it tells you here and here. Determine the values then of the degrees in X and Y.
So we're trying to solve here angle X and angle Y. Well, let's look at this a little closer up. So we'll just zoom into the problem. Okay, so let's take a look at this problem here. So we are told that line segment OC is intersecting chord AB. And since it's traveling through the center, we know that it's a perpendicular bisector. And they're telling us that anyway, right? That these two line segments are of equal length.
So from our chord properties, we know that if it goes to the center of the circle and then it's a perpendicular if it's a bisector, then we know it must be perpendicular.
Right, so I guess we could put this in anyway. We know it's forming a 90-degree angle. Okay, what else do we know? We know that the length of O comes from the center of the circle and it travels out to one point, and here it's point B. So we know that that's called the radius, right? We also know that again, this line segment, OA or AO, is traveling from the center of the circle and it is hitting at point A here, so that's also the radius. So we know that these two lengths are the same, right? Therefore, what do we know about this type of triangle? If it has two sides of the triangle that are the same length, what do we call that type of triangle again?
It's called an isosceles triangle.
Perfect. What else do we know about isosceles triangles?
So for it to be an isosceles triangle, the angles across from the equal sides must also be equal. So from across from here to here and across from here to here, these angles must be equal.
Okay, so therefore, if this angle is 33 degrees and this is an isosceles triangle, angle X must also be 33 degrees. Okay, so let's just put that in here. All right, so now we have to use this information and somehow try to figure out what angle Y would be. So how are we going to do that?
All right, so if we know that this angle is 90 degrees, that means that this is also a line. So in this case, this has to be 90 degrees.
Okay, so that's a 90-degree angle.
For it to be a perpendicular bisector, it must be 90 degrees on both sides.
Right, because it's a straight line.
And we can again go back to the sum of our angles in our triangle property and solve for the third angle here because we know they must equal 180 degrees.
Right, so now that we've identified that this is a 90-degree angle, we have a 90-degree angle, a 33-degree angle, and our unknown. So we're going to take 90 degrees and we're going to add it to 33 degrees. And that equals 123 degrees. All right, and to solve for y, just like Mrs. F said, we're going to subtract that from 180 degrees. Whoops, 23 degrees. And that is equal to? Sorry?
Right, never mind. You're right.
Yeah. And when we subtract the 2, I'm like, that's right, isn't it?
That looks right, sort of right.
It equals 67 degrees, right? When you subtract the 2. Hopefully you didn't need your calculator for that one. All right, so angle Y is 67 degrees. Perfect. So we've just solved unknown angles using triangle properties and chord properties.
Great, good job.
Perfect.
All right, let's turn to practice question number 2 so that we can look at solving unknown chord lengths now, knowing the chord properties.
Okay.
So if we are told that point O is the center of the circle,
Okay.
AB is a diameter with length 26 centimeters because it does go through the center.
Okay.
CD is a chord that is 10 centimeters from the center of the circle.
Okay.
What is the length of chord CD?
Okay, so we're asking to find the length of this. So let's look a little closer at this question. Okay, so here's all of our information, and we're asked to solve the length of CD. So line segment CD. All right, so let's look. One of the things we need to think about is getting right triangles, right? We're obviously wanting to apply Pythagoras' theorem to solve for unknown lengths, so you're going to want to have a right triangle in solving this. And don't be afraid to draw in line segments that aren't actually there given the information that you're given. All right, so we're asked to solve this chord, and therefore we want these line segments, either CE or ED, to be part of a right triangle. They're not right now, so we're probably going to have to draw in an extra side to that triangle. We're also told that the diameter is 26. If the diameter is 26, what would the radius be then?
It would have to be half of that, which would be 13.
Okay, so we know that each of these, we'll just put that in there, are 13. So I'm going to choose line segment CE. I want it to be part of the right triangle. I've got this line segment, because it's bisected, all right, we know that this is a bisector. We've got a 90-degree angle here as well. I'm going to draw in that third side of the triangle starting from center O out to C. And really what I'm drawing in here is a radius. And because we just figured out that that radius is 13 centimeters, let's add that information. So now what are we going to do?
Okay, awesome. So let's talk about what we know in terms of chord properties now. All right? So we know that this is the center of the circle. We know that this is also perpendicular. And so in order for these two things to be true, our third property of chord properties needs to be true as well, which is that these would be bisectors. This would become a perpendicular bisector, so line segment CE and line segment DE would also be equal.
Right, so we know that the length from E to D and the length from C to E are going to be equivalent. So if we find one of those lengths, we can add them together and that would be the entire chord. So I guess now we're going to apply Pythagoras' theorem. We've got a right triangle, we have two sides identified, and we just need to solve for the third. Okay, so we have the hypotenuse labeled here, and one of the shorter sides, and so let's just call this side x. Okay, and so which values are we substituting in here?
So for A, we can put in x.
Okay.
And for B, let's put in the other smaller side, 10.
Okay.
And as always, C becomes our hypotenuse, which is 13.
Okay, and just like in the previous examples of solving Pythagoras, we'll simplify this. So this becomes x squared, 10 squared is 100.
Not 20.
Yes, and 13 squared is 169. Okay, and now, just like Mrs. F has said before in previous videos, we're going to solve by balancing. We'll subtract 100 from both sides. Alright, and our last step always in Pythagoras.
You have to take the square root of both sides so we have the inverse.
Okay, so we're going to square root x squared and square root 69. We're left with x, well it's going to be 8 point something. And what do we get? Let's round it to the nearest tenth, it said. So 8 point, give me the first three digits.
306.
306. Alright, so if we're rounding it to the nearest tenth, the 33 is in that place value. Looking at the digit after it, it's a 0. So it would be 8.3 centimeters.
So remember that this is just for our x, and if we want to solve for the entire chord across here, we'd have to multiply this by 2, or add it together. Usually we like to do this before we are finished rounding, so that we get our most accurate answer, okay?
Absolutely, you should have done that first. In this example, it won't matter, right?
Yes.
Okay, so when we add these two together, it becomes 16.6 centimeters. Okay.
And that's our final answer for the entire chord, C to D.
Perfect, good job.
Alright, so let's look at your next example, practice question 3, and this is where we'll be solving an unknown chord length of a real world problem knowing chord properties.
Ooh, real world math.
Here we go again.
Okay, let's take a look.
A horizontal pipe has a circular cross section. With a center at O, its radius is also 20 centimeters. Water fills less than 1/2 of the pipe, so the blue stuff there.
Right,
The surface of the water, AB, is 24 centimeters wide.
perfect.
Determine the maximum depth of the water, which is the depth C to D.
So this one. Okay, so let's look at this question a little closer up. Okay, so we're going to have to label some of the information that was given in the word problem, but it wasn't actually on the diagram here. So the one thing that the question said to us that was the surface of the water. So chord AB is a length of 24 centimeters. Right?
Perfect. Let's put that in. It always helps to label your diagrams with the information that you aren't given so you can see everything on the picture.
Okay, so from here to here is 24 centimeters. Let's look at what other information we're given on this diagram, and we can use that information to help solve the problem. So we have the radius from O to A labeled 20 centimeters. We also have another radius drawn coming from point O to D. So what do we know about that?
We also know that that would be 20 centimeters.
Perfect. We also should notice that the radius is cutting this chord and forming a 90-degree angle. So what do we know about that?
We know that if it's at a 90-degree angle and it goes to the center, then it has to be a bisector, which means that segment AC to CB are also equal.
Perfect. So if all the way across from A to B is 24 centimeters, A to C would be half of that.
Which would be 12.
Okay, so let's put that information in. that each of these are 12. Okay, so let's see. We are asked to solve this line segment here, CD, this tiny one. All right, we know that this is 20 centimeters. We know that that is 12. And we also know that this triangle formed here is a right triangle. So what theory are we probably going to use again here?
Probably again, Pythagorean. And notice that right off the bat, this isn't an easy one-step problem. We are not going to be able to do this in just one step. So let's use what we know about Pythagorean and see where that gets us.
Okay, so if we're using Pythagoras' theorem, we have this side of the triangle identified, this side of the triangle identified. It's this third side unknown, so from O to C that we're going to solve. So let's go a squared plus b squared equals c squared. All right, and a will be?
Let's, first of all, let's label O to C as x.
Okay.
And then we will put A in as x then.
Okay, so x will always be our first one here, squared.
Our b squared could be our 12 along the bottom, our other leg.
Okay.
And then our c, again, always the hypotenuse or the longest side, the side across from the right angle.
Okay, so let's simplify this. X to the power of 2 is x squared. 12 squared we know is 144. And 20 squared is 400. Okay.
Awesome. And like normal, let's keep balancing the equation so we can solve for x and isolate it and get it by itself.
So we'll subtract 144 from both sides. We're left with x squared is equal to, all right, a little bit of mental math here. It would be 256.
And just so we can check if it's reasonable, I use the calculator, and she's definitely right.
Okay, so our last step always in Pythagoras' theorem is to do the opposite of squaring. So we're going to square root both sides, and we're left with x is equal to
16.
16. Perfect. Okay, so we know that this length of x is 16. Okay, I'm just going to use black here. So I'll take away x, and now we know it's 16. But we're not asked to solve for that length. We're asked to solve for length C to D. So what other information can we use to figure out line segment CD?
And remember that O to D we were told that that's our radius. And if this is also our radius, then we know that this whole segment here, the whole radius here is 20 centimeters.
So OD is a radius. It would also be 20 centimeters.
And if we know that from O to C is 16 centimeters, we can easily solve from C to D using 20 minus 60.
We're just going to subtract the two. All right, so if you take the full length, which would be 20, take away this line segment, 16, we're left with 4 centimeters.
So line line segment CD, or just the water
Right, the depth of the water,
yep, will be
4 centimeters.
Nice
Perfect.
work.
Good job.
Well, that wraps up another great video.
Nice job, Mrs. F.
You too, Mrs.
Yeah,
H.
we did excellent.
Okay, Mrs. H is going to say some smart stuff now about chord properties.
All right, well, let's just summarize everything we learned in the video today about chords. So we learned that a perpendicular line to a chord will bisect that chord. Oh, sorry, we got to start again. Perpendicular line from the center of a circle. Okay, start again.
That if you get that part right, then you'll get the rest
I'll be
right.
fine.
Yeah. Okay. Well, that wraps up another great video.
That was an excellent job, Mrs. F.
You too, Mrs. H.
Kudos.
Now Mrs. H is going to say some smart stuff about chord properties.
All right, well, let's put everything together about what we learned in the video today about chords. So we learned that a perpendicular line from the center of a circle to a chord bisects that chord, right? Meaning it splits it into two equal parts.
That's right, at a 90-degree angle.
Perfect. And then if we work in reverse, we know that a perpendicular bisector of any chord must pass through the center of the circle.
That's right. Good job today.
Nice job.
All right, so the next video, stay tuned for, we will be talking about properties of angles in a circle.
Perfect. And one video closer to hopefully getting some pie. Nice job.
Hang in there for some bloopers.
See you later. Okay.
I'm yawning first.
Yawn.
I'm getting a little bored of my own work.
It's bad when we're bored with our own video. Put that in the blooper.
Yeah.
Okay.
And pause.
Yeah. Okay. Perfect. That'll have to be good.
Oh, yeah, I don't care
Okay.
anymore.
Seriously.